program here named simulation is hopefully going to show you why we use computers so much in scientific research for modeling and things, although this example is going to be pretty basic. So we'll be using some random numbers. So we'll have to include the time.h header at the top there. Okay, so what we're going to do is we want to determine the average number rolled with 2 dice. Okay. So we roll 2 dice, we add them together, and we should be able to figure out, what the average number that is rolled. So here's how this is going to work. We're going to have die 1 and die 2. Both of these are going to be, your standard 6-sided dice. And then we're going to get a total. Total equals 0. Okay. And then what we're also going to do is we'll have an average value that we'll be calculating. And then we'll have a constant int. And this is going to be how many times we are going to roll these dice. So let's go with 100. Okay, and then we will set the randomization here. So srand time null. So we'll randomize the first number that we get. And then what we're going to get is we'll create a for loop. And we'll go int I equals 1 all the way to I is less than or equal to rolls. This is like how many attempts we're going to make. And then in here, die 1 is going to be the random number. So we want to do 1 to 6. So this would be like 6 minus 1, which is the high number, minus the low number, plus 1. So which is just 6. And then the low number in the range is 1. And then the D2 is going to be the exact same thing. So random modulus 6 plus 1. And then what we're going to do is we will get a total equals total plus D1 plus D2. So we're not actually, getting an individual total of those 2 values and then adding it on to a total, because, we're just really going to be adding all of these dice together. And then afterwards, we're going to have the average be equal to the double divided by rolls. Now, what we need to do here, because, sorry, this is supposed to be total. This is supposed to be double total, because we are going to have this integer and this integer as a division, but we want to have some decimal places kept. So we need to typecast one of the values as a double so that this will not become an integer division, but it will be a double division, and it will retain some of the decimal places as well. Okay, so now what we're going to do is we're going to output the average. So the average is average. Okay. So let's run the program and then see what happens. So I want to find out, when I roll 2 dice, I want to find out what the average number is that I roll. So I'm going to run this, and we get an average of 7.06. So I'm going to run it again. Now, because we're dealing with random numbers, we're going to get a range here. So 6.88, 7.13, 7.26. So we're bouncing around a little bit, and I want to get as close to the number as possible. So what you're going to find is it really matters how many trials you put on this this amount. So if I'm doing 20, let's watch how the variability in our result increases and decreases. So I'm going to run it 3 more times. Now we got 6.75, which is even lower. 7.2. So we're still kind of bouncing around the same values, except the variability is much higher. So we'll just try it a couple more times. 6.25 is very low compared to anything that we did. So what we want, 7.7 is crazy. So what we want to do is we want to get as close to the number as possible. So we are going to do this. Let's say 10, it's 100,000 times. So what we're going to do is we're going to roll these dice 100,000 times, and we'll see how the variability shrinks. At 20, it was between 6.25 and 7.7. So with 100,000 rolls, let's see what we get. Okay, 7.00009. We'll try it again. 6.9958. And 7.00221. So you can tell when we increase the amount of trials, we get much closer. There's much less variability in the numbers. And you can see that this is essentially, it's bouncing around the number 7, which is the true average if we were to total up all the possible results. So the lesson here is when you're doing trials or an experiment, you want to keep the amount of times that you're doing it quite high, because then the average you get is much closer to what the true average of any system should actually be.